Hello and welcome to part 2 of the transfer hook deep dive series. Today we're gonna have a closer look on adding more accounts to our transfer hook program. Actually, change of plans. In this video, we're just gonna look at discriminators. But don't worry, in the next video we'll actually get back to transfer hooks. And the long-term goal of this series is that you're able to create a token with custom functionality as you like it, and we will get there, don't worry. But the token extension transfer hooks are just so complicated that we need to go through the fundamentals first. Because only if you really understand what's happening beneath will you be able to properly implement the functionality that you really want. With that said, let's revisit what we did in the previous video. By the way, if you have not seen that, watch that first. That's the basis for this video, where basically we built this very simple hook program that just has this transfer hook instruction that is mapped to this specific discriminator such that the execute commands call this instruction. And maybe we want to revisit that for a little bit more. Maybe that hasn't been super clear in the previous video. Before we had that custom discriminator, we had the fallback. Let's also revisit the docs. This fallback instruction. We first had to use this because we couldn't define a custom discriminator. So basically here we are then mapping the specific discriminator of this execute to our transfer hook. The nicer way is to just set the discriminator like this. And there's an even nicer way I learned. I read that somewhere here as well. Currently there's an unreleased anchor feature that simplifies this process. It would remove the need for the fallback instruction. And I think that is not unreleased anymore. That's, I think, just out of date. And either they're talking about this discriminator thing, but they might also be talking about an interface. Anchor also has an Where did I read this? I read that somewhere. The quick note guide, it also talks about that fallback. Before the 0.30 release, we need that fallback. But look at that. Note that the interface macro was added in 0.30 and is used to override Anchor's default instruction discriminator. So they are using an interface that looks like this. So even cleaner than what we did so far, even cleaner than setting this discriminator, is to set this as an interface, SPL transfer hook execute. And we need to make sure that we have that. Do we have that? The SPL transfer hook interface. But I see a namespace here. This is also interesting. We'll get to that in a second. Let's first see if that would just work. If I say this, no, it wouldn't, because cannot find attribute interface. Import anchorlang accounts interface. Okay, then interface is imported here, but it's a module, not an attribute. How would I work with this? Interface. Here it's also using that interface. And what do you import for that? I don't see that it imports anything like specific. You need to import the interface macro from Anchor preload. Didn't I do that? How can I get this to work? Here we are again not understanding how Anchor works. Probably need to enable some kind of feature that Anchor has. And I don't know how. And Anchor is used for instruction discriminator overrides, yes. Enable you to define custom discriminators. This was added in 0.30. You can find this feature mentioned in the changelog. Oh, deprecate interface attribute. Okay, so we don't have the interface anymore in 0.31. Was it replaced by something? Adding support for custom discriminators made the interface attribute redundant, since the only thing this attribute does is override the instructions discriminator. Great. So, I mean, welcome to Anchor development, where most of the things you find are out of date and you need to check the changelog. So the way how to do it properly now is to do it as we did with setting the discriminator. Many ways to achieve the same thing often leads to confusion for users. You know what else leads to confusion for users? Adding something and then in the next version removing it again. Especially if that made it all the way to, you know, reference programs and docs. Just saying. Okay, anyway, but we figured it out. That's what I'm here for, helping you figure this shit out. And add a deprecation notice explaining how to migrate. Well, yeah. Did I find that? No, did I not. So that note was kind of pointless. So that is not being used anymore. We go back to instruction with discriminator, but the nicer solution from the instruction getting the discriminator like this, and we import the actual instruction that we want to have, the execute instruction, from the SPL transfer hook interface. So maybe let's do this instruction. But how do we get to the discriminator? The trait is implemented but not in scope. Perhaps you want to use it. Can we use it? Maybe I then need to cargo add. No, look at that. No, still not. Different error now. Is there anything else in this instruction that can give me the expected U8 slice? And we got the instruction. How do we get to the... Okay, let's look at this instruction. Execute instruction. That is just the type like we used in the fallback. The execute, that's the function. Creates me this instruction. How do I get to the... Yes, I'm playing around with stuff that is not super relevant, but I want to find the nice way to do it. I mean, I know the discriminator. I can just hard code it, but that's not as nice as taking it from the actual library that handles it. Do you have an actual code example for this? I still don't know what this is. It's not a thing. It does not exist. Again, welcome to Anchor development. The code seems to be what I want. We need SPL discriminate, SPL discriminator. Maybe you don't need the slice, but the discriminator. No. Okay, now we're getting somewhere. So I must not import it here in the transfer hook module, but out here, then suddenly stuff changes. And now I just have a type mismatch because I want the slice and I found the array. So again, giving you the slice. And suddenly it works. Okay, so what I needed to import was the SPL discriminator, SPL discriminate out here on top level. Things you gotta know. And then that seems to work. And that should be the same now as here. I can just for fun also, you know, log that stuff. The discriminator is, and then I will print this slice. Just to see what it is. And just to prove that that's the same thing still, let's try and do a transfer again. A simple transfer. There we go. That works. We are transferring. Oh, obviously. Classic. Forgot to build and deploy. That happens sometimes. And 210 transactions later, we do the same thing. There we go. That's what I want to see. And here we see that the discriminator is this stuff, and that corresponds exactly to what we hard coded last time. So we now also know where that comes from. We don't know why it has that value exactly. We want to also, should we do a deep dive on discriminators? I mean, while we're here, might as well see where that really comes from. Because, and I also tried that, I just didn't show you. It is not the same as if I had an instruction that I call execute. If I build this, and we don't even need to, you know, call it, I can just check the IDL. The execute has this discriminator, and the token transfer has this discriminator, because that's what we overwrote it to. So this is not it, but it's close. So what is it? Because we do have this 8-byte discriminator. It must come from somewhere. It's like it is some kind of hash of something. Maybe let's remind ourselves how Anchor does it. Let's revisit how Anchor does the default discriminators if we don't overwrite it. And because I'm lazy, I'm going to vibe code. A quick TypeScript script. Vibe coding. So we use crypto to get the SHA-256. I'm going to call this get discriminator. And then I just get the first 8 bytes from this. Yeah, exactly. So how Anchor does it, it builds a hash and gets the first 8 bytes as the discriminator. And what does it take the hash from? It takes the namespace, double point, the function name. That's how Anchor does it. And our function name in this case would be execute. And our namespace in this case would be, I think, global. Let's see. then the discriminator would be 130, shalalala, 29. Is that also what we see in the IDL for the execute? There we go, 130, 29. Doing a deep dive on discriminators. That would be the case with anchor. And just to prove, if we wouldn't set the discriminator here for the transfer hook and we would build this again, build our IDL, then the discriminator of the transfer hook function would be this, 220, 57, 220. And if I get the discriminator for global double point transfer hook, it tells me the discriminator is 220, 57, 220. Shalalala. So this is how Anchor builds or chooses the discriminator. First 8 bytes from a SHA-256 hash of the name, such that it's deterministic. And I mean, 8 bytes is 8 bytes. It's a lot, but whatever. That's just what they decided on, and that's fine. But the question still remains for our execute. Where do those bytes now come from for this actual execute instruction? Let's look at the source code. TLV account resolution. SolDiscriminate for my instruction. Repository. Discriminator. The discriminator struct. That's where this comes from. That is the SBL discriminator. Discriminator hash input. Some discriminator hash input. Oh man. Are we just doing a deep dive on discriminators today? Because I could do an entire video just on that. So it's not just anchor, this is really SBL discriminator. Let's play around with this. Today we're gonna do a deep dive on discriminators, sure. Let's do cargo init, cargo add, what's it called? SBL discriminator. Let's just play with this library that we also imported here. Let discriminator be new array discriminator. There we go. We can import the array discriminator and then we can say slice. I'm just gonna print this. There we go. Then we have this U8 slice. Let's see. Cargo build. And then we get discriminator is this because we set that as the array discriminator. I mean, so far so simple, right? I mean, well, we didn't really do anything except, make an array discriminator and then get the slice from it. And obviously I can put, any discriminator here, for instance, the one that we know from the execute instruction. That's this. But that's still boring. More interesting is this SBL discriminate macro using your declared string literal hash input. Okay, hold on. First, let's do this. That's the step before. Let's do new with hash input, because instead of, hard coding the bytes, I could say array discriminator new with hash input. And the hash input, that's also what we had in this example. That's this input. So I could say global execute string. And then it will do the same thing, I suppose. I haven't tried, but let's try. Boom, there we go. The 130, 29. We remember this. Or the transfer hook. Remember this. 220, 57, 220. That does the same thing. So if you ever wondered what's behind this, it's a SHA-256 hash taking the first 8 bytes. That gets you such an array discriminator. And then from the array discriminator, we can get it as slice and get the bytes back. Then we have, this again. Okay, so that's how this works. And apparently that's also then what our actual execute instruction does. That probably uses this trait such that it gets the SBL discriminator and the discriminator slice, where we see that the slice is once again just the slice from the array discriminator. So we could have something like our instruction where we derive the SBL discriminate, check this, but then it doesn't know what it should derive this from. It needs the hash input, but that wasn't provided. So we need to provide that hash input. And we could say, let's do global transfer hook, or let's do whatever, our instruction. And then we can say discriminator of our instruction is our instruction SBL discriminator slice, which behind the scenes creates an array discriminator with a hash input and then does discriminator as slice. That's what's behind this. And so that would be the discriminator for this input. I think now we understand how this SBL discriminate works. It's so cool from one thing to the other, right? I wanted to work on transfer hooks, but I'm working on discriminators because I want to understand it all. And that's why this series is, 10 parts long. I don't know how long it's actually going to be, but, probably 5 parts. We'll see. And so we see that's also exactly what we're doing here, getting the discriminator from the execute instruction. And now we understand why we need to import this part. We need to have the SBL discriminator such that this implementation is in scope. Because otherwise it wouldn't know, how to do this thing. But that still doesn't answer the question, what is the hash input? And the hash input, to find that, we will need to go, to the execute instruction. Where does that live? That lives in SBL transfer hook interface. Let's see if we find the source for that. That's in Solana program transfer hook. Entry point, processor state, processor. Let's see. Process execute. But no, that's also not like where is it defined though? Lib. Look at this. I found it. Instruction, transfer hook instruction, execute. Do you see this? Do you see this? The execute instruction does exactly what we just said. It derives the SBL discriminate with the discriminator hash SBL transfer hook interface execute. What is the SBL transfer hook interface? We just saw that here in the lib. That is the namespace for all programs implementing the transfer hooks. SBL transfer hook interface is the namespace. So we again have the namespace colon function name or instruction name, namespace instruction name. And this, if we were to plug this into our instruction, then it will have the same discriminator as we used here for this transfer hook. Because those are the bytes that the SBL token program, token extensions, token 2022, will use when doing the CPI. It will have those 8 bytes plus 8 bytes for the amount of tokens that it transfers. That's what happens here. And that is the deep dive on discriminators. Should I for once do a video that is less than half an hour long? Why not? That's so cool though. Understanding the SBL discriminate, how you can set that to your instruction, and then in Anchor, how you use that discriminator for any given function. So set this custom discriminator. That's so cool. And that reads much nicer than, a hard-coded 8 bytes, right? So much nicer. I love it. And somewhere in between we had this interface implementation, but forget about that. That's not a thing anymore. We do it with instruction setting the discriminator. That's how it's done. By the way, just because I wanted to see that as well. In here, we also had the namespace, the SBL transfer hook interface namespace, which is SBL transfer hook interface. I don't know why Anchor uses global. It's the default, I guess. But namespace is used to have clear distinctions between crates that an execute instruction in the SBL transfer hook interface crate is different than an execute instruction in, any other. That's why namespaces. Yeah, anyway, so that's cool. I'm gonna end this video here. This is good. This was good. I enjoyed this. We learned how those discriminators are built. We learned how instructions or interfaces add them with that input hash. And we learned how we can then take it from such an instruction or interface and use that given discriminator as a custom discriminator for our instructions. That's a good short little video. I like it. Hope you enjoyed it. We're not done. We're gonna continue talking about transfer hooks right here. Right here is the next video for transfer hooks. Here's another random one. Like this one if you enjoyed it. If you didn't, why did you watch it? I enjoyed it, and that's all that counts. No, that's, I mean, and I hope that some of you did too. This is just my favorite way of learning, you know, having a goal of getting somewhere, and then on the path, redeciding to look at something completely different because it's also relevant right now. I love learning like this. So if you want to continue learning like this, I've got plenty of other videos, and I will see you in the next one.